Wagwan Jamaica. Welcome to Schools Not Out, your daily classroom for CSEC and CAPE students. Today's lesson is on CSEC Information Technology. I am Leah Lewis. So we'll be looking at programming this time round, and we're going to try to make some kind of effort to break down each and every step for you as it relates to how we solve programs or how we even write programs for computers. And that is the issue we need to deal with essentially when it comes to the actual CSEC syllabus. Many persons have said that it's the hardest part of the syllabus, but I guarantee you, when you're finished, you will be quite good. With that said, this is my tip for the day, or my first tip for the day. And the thing is to get the logic correct, all right? We want you to get the logic correct. And so that is why it's important that you pay attention to the problem and what the problem is asking you for. You want to pay attention to what the needs are, how you can get them, where you're going to get them from. Let's say, for instance, you want to create a better headphone than the Beats headphone. There are some things that you need to pay attention to. You know, what does better mean? Does it mean a better sound? Does it mean a better frequency response? Does it mean that it's more comfortable? And so you have to be able to draw that problem or give that problem scope. You have to give it a boundary. You have to give it delimiters, all right? And then when you have decided on that, you want to think about what the solution could be, all right? You want to think about, how am I going to really arrive at this? First and foremost, you might want to think about, hey, maybe I don't know how a headphone works. So I need to know how a headphone works. I need to know what the frequency responses are at a headphone. You know, I need to know all these things, and that is what you need to do. Sit and think about it. And finally, you want to pay attention to the actual solution, or just breaking down the solution into tidbits that you can handle. And that is where programming truly comes in. Break down each part of your solution into manageable steps for a program, all right? And that is what we're going to try to do today. As we go through, the first thing that we want to pay attention to is the different control structures. I call them building blocks. Now, these control structures help to sequence, help to structure how the program should work, all right? And the first one that we'll be looking at is a simple sequence. Now, a simple sequence is just that. One step being executed after another. No change in the order, just like a simple list. And the list runs from one through to wherever it ends. As you see on our screen, or as you may see on our screen, we have a simple sequence program, and we have, or a pseudocode rather, and we have it running from start all the way down to a stop. And all that it's supposed to do is to print the name and age of one person possibly. All right, so we have start, and then I initialized two variables called name and age. And that initialization process is where we give each variable a starting value. So for name, I've given the starting value as 3 A's. Age, the starting value is 0. Now, maybe you have been taught this a different way. Maybe your teacher decided to teach you by making these variables, giving them their possible data types right off the bat, like string, integer, real. You can do that here as well. You're just initializing the variables to ensure that you have a starting value in them. Then we print a prompt telling a user to enter a name. And that prompt would read print, double quotation mark, enter name, close quotation mark. And the things or the words between the quotation marks are going to be printed directly on screen. After that, we read the name itself. And this has no quotation marks, you just have the word read and the variable name, name. Then we go ahead and do the same kind of thing for entering age, which is basically print a prompt to the user to enter the age, and then we allow them to read the age. And finally, we print the name of the person and the age of the person with a simple message. Now let me just break down this message quite quickly. If we're looking at our screen, or if you're looking at the screen closely, you will see where name is not in quotation marks, followed by a comma. What that means is that that variable will be printed, or the value of that variable will be printed, not the name itself, or not the word itself. The value inside name would be printed. After the comma, we have the word is in quotation marks with a couple spaces. That's going to be printed exactly on screen, or that is what we want our program to do when we write it. And the same convention follows throughout for age and years of age. All right? And then immediately after, we have a stop. And so that is how we break down our simple sequence. It's just one basic code running right through that does one thing after the other, no change involved. All right? And if we jump now, we're going to jump straight into how we represent it in flowcharts. Now, just to remind you, flowchart symbols are significant and you can't just use them interchangeably. We have several different symbols that we use here, and we want to be specific about each one that we are using. The start symbol is normally, or start is normally in what we call a terminal symbol. And we also put the stop symbol, or also put stop in that way as well. The process symbol is a rectangle, and you can see what we're using it for. It seems as if we're using it for initialization. There are different conventions, I must say, that have to do with what we use, what symbol we use for initialization. For this context in CXC, we tend to use the rectangle. However, in my own teaching, I use a hexagon, which is a preparation symbol, and that I think comes from UML modeling. But you will learn more about that when you go to university. And then we have the input-output symbol, which you already know, the flow lines, of course, with an arrow at the end, and then connectors. And we're going to see how all of this come together as we go on. And then we're going to look at how our simple sequence looks with our flow chart. All right? And if you notice, the flow lines are running from start through stop, but it's going through all the different statements we had before. Immediately after stop, we have the initialization where we have name equal AA and age equal 0. And that is in a process box. After that initialization process, we have a print, and this print comes in the input and output box, and we just put print, enter name. After that, we have read name. And of course, there's no quotation marks around the name. And why I have separated them, or separate both boxes, is because one is doing an output and the other is an input. So you want to separate your boxes whenever you're doing a print or a read. You don't want to have print and read in the same box. Try to separate them, all right? And then, of course, the code continues all the way on to stop, where we finally print a message, all right? So that's simple sequence. Pretty easy, pretty straightforward, but I guarantee you, you will not get anything like that on the exam. The exam is going to be a little bit more difficult than just simple sequence, which means they might involve the use of if statements, the use of loops, which is what we're going to do immediately after this. All right, so here now we have our actual Pascal code. And our Pascal code is where most people tend to think that, boy, this thing does not work and make no sense. As I said last time when I came, the most important thing about programming and problem solving is to get the logic right and then swat the code. I'm whispering it so that your teacher not hear. Get the logic right, swat the code syntax. Where you have a start symbol or where you have a start in your pseudocode, it translates to the Pascal program saying program simple sequence, semicolon. And I must admit that many of the times when I see students write programs and they have program and the program name, they leave off the semicolon. Again, don't leave it off. It is wrong if you leave off the semicolon. Also, you want to pay attention to the fact that the name, simple sequence, is one word. You don't use two different words separated by spaces. One word for your program name, semicolon, that is it. You're done. Then after that, we want to declare our variables. And in this case, our variables were name and age. And this declaration process is where we give each one its particular data type. In this case, name is a string and age is an integer. After we've done our declaration, we need to do the initialization. So in pseudocode, we did everything once by an initialization. In Pascal, you declare, then you initialize immediately after you begin. Again, last week we said that Pascal did an initialization process for you at the start of your declaration. So Pascal gives it an initial value when it is declared. However, it is good practice to do your own form of initialization, because when you decide to go further, if you decide to do any form of programming, then you'll learn that there are some programming languages, it is mandated that you initialize after you have declared. All right? I have some students now, well, not I, but there are some students now who I used to teach, and they're in universities abroad doing engineering. And they said to me, sir, you need to teach all your students programming, because the truth of the matter is, half of the things that we do, it's being done on a computer and we have to program the software ourselves. So guess what? Maybe you want to be an engineer, but you hate programming. You kinda go dark. You have to learn to program. All right, so let's move on. Then we have where we basically have a prompt statement, and the prompt statement was print, and in quotations, enter name. In the Pascal code, we have write ln, and that's the word WRITELN, open parenthesis, single quotation mark, the words enter name, close single quotation mark, close parenthesis, and semicolon. All right? And that is the syntax. And I'm trying to make a parallel between the actual pseudocode and the syntax for Pascal, so that you can see that it's just a matter of you copying the code or copying the pseudocode into your compiler and changing the syntax based on what you want to be done. All right? And then we have read name, and this read name, straightforward. All right? We use the same thing in the pseudocode, and so therefore we're using the same thing in the Pascal code, with the addition of the parentheses and the semicolon. All right? And it goes on from there, and that's simple sequence. Easy stuff, and let's push on. There's one thing that we did not do, and it was to look at commenting. And we don't want to leave commenting off. The truth of the matter is, whenever you write a program, you want to be able to identify what sections of the program you were working on, what they're doing. There was a friend of, well, not a friend of mine, but I was designing a website and I did it in Flash. And I had a whole heap of action scripts to write. And when I was finished programming, I had like 1,000 lines of code alone. And I thought to myself, I'm just going to put in a little bit of comments here and there. When I finished the program and came back to it a month later, I had no clue to what was there. Because the logic that was going on in my mind, I just took it and put it on paper, or put it on the compiler. What this commenting does is to help you to identify what is happening in your program, when it is happening. And the first kind of commenting we have is multi-line commenting. And of course, these are fictional characters. My name is not Falstag Fist Bumper, but you can get the gist. So when we're doing a multi-line comment, we have a curly brackets to start, or the opening curly brackets, the left one. And then we have the right one closing the entire comments. But when we're using multi-line comments, it means that we have several lines of comments to write. That's all that means. In this case, I have the name of the programmer, false tag fist bumper, then the name of the program itself, which is simple sequence.pascal or PAS, and then the date of creation, the description of the program. Of course, some of my students tend to leave this off, but there's a greater issue when you leave your comments off. One of the reasons why this is important is because software engineering or software engineers knew that as they created codes, it was part of what is called intellectual property. When you write a program, it is your intellectual property. You own that program. But if there is no evidence of you owning it, you cannot claim it. Well, you can't claim it in a court of law. So this comment at the top that date stamps your program, puts your name on it, is a part of what we call copywriting. And we learn that as well in computing, that whenever we create things as computer professionals, we want to copyright it. Now, there are many kind of ways to copyright, but this commenting is a part of you copywriting. All right? And this is the multi-line comment that comes before the actual program starts. The next kind of comment is what we call an inline comment. And it's just one statement that takes up one line. And we tend to use the 2 forward slashes to signify that. And in this case, we just have one comment that says variable declarations. And before that comment is the 2 forward slashes. And that comment, that is good for that comment. Just to remind you also that comments are not executed. So when your compiler sees that, it's simply saying that don't execute this section of your code. One of the things I tend to do when I was in university was that whenever a code wasn't running or whenever I found a problem, I just comment out sections of the program so that the compiler would forget about that section, and then I could basically narrow down my errors to one section of the code. You can try that very same thing as well. And for those of you who can get online now, there are a number of online compilers of Pascal, and I'm sure that they'll serve you just fine. All right? Let's move on to the if, then, else structure. And this is what we call conditional branching or decision making. All right? And the structure is that we have an if, or the word if, conditions follow if, and after those conditions comes the word then. After the word then comes a set of actions. Then we have else, then a set of actions, and then end if. These actions can be any number of things that you want. Print statements, other if statements, for loops, while loops, anything that you want can go inside, or where we see actions, you can put anything there. The important thing is that you end and start each section correctly. And that is why we have then, else, end if. Each section must be correctly delimited or stated. For example, if you look at this code that I'm going to put up right quickly, we have the starting if statement or an outer if statement. And this just have the same kind of structure. If conditions then, and inside that we are putting another if statement. And I'm trying to put colors to them so you can actually see what's going on. So the outer if statement is in green, and inside the then section of this if statement is another if statement, and that is in red. And I'm being careful to make the structure of that inner if the same as the outer if. So it has a if, it has a then, it has an else, it has an end if. And then we have the else or the outer else, which is in green. And inside that else statement, we have another if statement, which is in orange. Same structure as the outer if. And so because we can nest statements like this, it allows for greater flexibility when we're writing programs. So that is the if statement in a nutshell as it relates to structure. Let's look at one particular question now. And of course, last week I was here, and when I came here, I was using, what was I using again? Oh, Jana's example. So again, shout out to you, Jana, if you're watching. I hope you're ready for the exam. But this week we're going to use another one of my examples. It's pretty simple, and we can go through it quite quickly. So what we want to do is to identify if a student has passed a subject where the passing mark or passing score is 75. And all we have here is a section showing what the if statement would look like if we had an if statement to do. So in this case, we have if score greater than 74, then print student passed. Else, print student failed in if. The condition says score greater than 74 because the passing mark is 75. And we're working with integer scores this time. So any score greater than 74 means 75 or more. And that, of course, is where the condition is placed and how it is placed. And then we simply print student passed if the score is greater than 74. And if the score, or if the score is less than 74 or 74 and less, then we print student has failed. Now that condition is what we're going to try to break down a little bit. It is important that you understand that as you write your own pseudocodes, no two persons or three persons will have the same kind of pseudocode because of how we think about our solutions generally. So guess what? If you had planned to cheat, I'm not giving you ways how to cheat. I'm not telling you what to change or what not to do. But if you cheat and you write the exact code, 0. So you can't have the same exact code. And I'm not saying you must cheat. TVJ don't condone cheating. I don't condone it either. All right. So let's move on to the condition. We had greater than as the condition, or score greater than 74. In this case here, where score is greater than 74, we can use other forms of the condition. We can use a score greater than or equal to 75. Same result. Same thing. All right? And then we can show the alternative. It would be the same kind of if statement. And we'd have if score greater than or equal to 75, then print student pass, else print student failed. The other alternative is that we could use a possibly less than condition, where score is less than 75, which amounts to the same thing as score greater than 74. Or we can go and say score less than or equal to 74. Same result. Difference is we'd have to switch how our if statement is structured. If we have the condition saying score less than or equal to 74, that means that the person has failed. So we really need to have failure or show failure inside of the then section of the pseudocode. If we have that in the then section, it means that we need to print student passed in the else section of the pseudocode. So please bear that in mind. You can use any one of these conventions you want, any one of these conditions or relations that you want, as long as the logic makes sense. You're not restricted to whatever you want to use, as long as the logic makes sense and as long as it heads to solving the problem. And finally, we will look at the flowchart. Again, we're simply placing the pseudocode into the different symbols. Again, we have a start symbol, which is a terminal symbol at the top. Then we do our declaration and initialization, which in this case we're using a process symbol or a rectangle. Then we have a number of prompts and read statements. In this case, print, enter score, read score. And even though some of you might be listening on the radio and you can't see this, we're using a connector this time. And this connector has a letter in it and has a color. Now the color is optional, but the letter is significant in that it helps us to identify where the flowchart is going. Our connector says A, and so what we do is to look for another A on our flowchart. And of course the other A is on the other side of the slide that leads you into the actual condition. And then we are seeing where we have a diamond here now, which is another decision symbol. All right, so you're seeing this for the first time. The decision symbol is where we put everything relating to loops and if statements. And what we do here is to write the word or write the condition score greater than 74 and put a question sign on it, because essentially it's a decision. So we have a question and that question leads to some kind of decision being made. Coming out of that decision symbol are two paths. We have a path that says no, a path that says yes. So we're answering the question here then. So we're saying, is score greater than 74? If the answer is no, then we follow the no path that leads us to saying student has failed. But if the answer is yes to that question in the diamond, and of course, remember, it is score greater than 74. Then the path goes on to yes. Or it goes to yes instead of going to no. And in this case, we're saying what? Print student passed. And all that leads to a connector that goes to stop. All right? And then we have our code. And our code is a simple decision code. Again, program, simple decision, semicolon. So that's the name section. We have the word program. We have the words simple decision, one word joined together, and semicolon. We declare our variables, and in this case, the variable is just score. And that's an integer. Then we initialize our variable. Print, enter score, read the score. Then we go into our different if statements. Now you notice that if statements here has the same look as the pseudocode, with the exception of the end if. And what we want to do is to pay attention to the fact that this end if could actually mean the semicolon. So there is going to be a semicolon at the end of the entire if statement. So we have if score greater than 74, then write ln, student name has passed, or student has passed, else write students pass, or whatever the case is there, or that should be failed, right? So I'm wrong this up, failed, and then the semicolon, all right? Straightforward. And then we have our read line statement, which serves to pause a screen or pause the screen as you work, all right? And that might be seen as not important, but when you do your programs, what will happen is that your program will just run on screen and then click off, because it's essentially text-based. And your program will not remain on the screen. Will not remain on the screen for any time whatsoever. So read ln pauses the screen to ensure that you can, of course, interact with the program and with the different elements of the program. All right. So let's just quickly look back at that pseudocode and the flowchart real quickly so that you can assimilate it and digest it just a little bit more. All right. So this is your flowchart and your pseudocode. And now we're going to try to jump into loops as quickly as we possibly can. There are three essential types of loops, and there are different functions for them: for loop, while loop, and repeat until. The for loop is normally used when we have a specific amount of repetitions to make. And so we actually know how many times we want this loop to be executed. It's normally a number, 5, 6, 7, whatever the case may be. Whereas the while loop and the repeat until loops are normally used when we're not sure how many repetitions we want to make, but we want to put conditions in place to ensure that the loop can be exited. And so the for is considered to be a definite repetition, a definite amount of repetitions. And while and repeat are more or less indefinite. So let's jump quickly to the structure of the for loop. The structure of the for loop is as follows. For some variable equals start to finish do. Then we have a number of actions inside next I or next variable end for. This variable here is any kind of variable you want it to be. In this case, we want it to be I. And that's why we have next I at the bottom here. The start can be any number. And the finish can also be any number. The convention, however, is to ensure that start is less than finish. And of course, there are other ways that we can perform this. We can go from finish to start depending on whatever the case is or how much repetitions we want to make. Let's look at a quick example. We want to use the very same example that we had with the if statement. But in this particular question, we want to change it so that we can count or do a count for a number of students. In this case, it's 40. So we're saying, count the number of students who passed IT in a class of 40. And the passing score is still 75. So we have now changed the problem to now reflect the use of a for loop just to count the amount of students. So what do we already know? We already know the condition under which a student passes. If the score is greater than 74, then the student passes. So we know that. What the problem now is presenting to us is that we have 40 students to do this very same operation for. And we need to count who has passed. All right? With that said, we change our pseudocode now to resemble that very solution. Note, we still have to follow the procedure, the protocol of initializing. And so, as we write our pseudocode, we put in start, then we initialize the variables we intend to use. In this case, the variables that we want to use is score, so that we can store the value of that score that is entered or any score entered. The variable I that controls the amount of iterations or repetitions of the loop, and the variable passed, which should count how many persons would have passed IT. So that's the initialization process. Straightforward, using all integers here. Then we go into the for loop. For I equal 1 to 40, do. And inside of that for loop, we now throw everything that we need for the particular solution to be realized. So we have a print statement that says print, open quotations, enter score number, close quotations, comma I. And it simply will come up on the screen as print score number 1, print score number 2, print score number 3, or enter print score number 2, etc., etc. So you're going to be prompted at each iteration or repetition which score to enter or what number. So if you have a score for 20 students or 40 students, it's going to run that print statement for 40 times and print enter score number 1, 2, enter score number 30, enter score number 40. All right? And then a read statement comes immediately after that print statement. And this is simply just to get the score in. So that read statement reads, read score. Immediately after that statement is made, we jump into the if statement that we used from the first example. and we simply tweaked it. We took out the print statement inside the then section and just added a statement to add or to run what is called a running total of those who have passed. So we have if score greater than 74, then passed equal passed plus 1. Now just to explain that quite quickly. The initial value of passed is 0. Which means that if we find someone who has passed, that statement is going to say passed equal 0 plus 1. And then that passed becomes 1. If we do a second student or a second score and that person has passed, the statement will now go to say passed, whatever passed is equal to what passed was, which is 1, plus 1, and that gives us 2. If we have a third score and the persons get 45, which means that they have not passed, what will happen now is that when we reach the if statement, instead of executing what is inside the then section, it will go to the else section because the condition is that the score has to be greater than 74. But 45 is not greater than 74. Hence, we're not going to do what is in the then section. We're going to do what is in the else section. Coincidentally, we don't want to count anybody who has failed. We're not interested in those who have failed. Well, not that we're not interested. The program not interested right now. So there is nothing to be done in the else section. And so what we have here is what is called a null else statement. Just an else in brackets. And then we end if. After we finish with the if statement, then we move on to ending the for loop by saying next I. And remember, I comes from the same I that we used in the for statement or at the top of the for statement. And it's just another way of saying count up, go to the next I. So if it was 1, then it goes to 2, 3, 4, etc. That is my convention. Of course, you can choose your own convention, but as long as you have the end for that follows it. Regardless of how you're taught it. For, end for. That delimits what goes into the for loop. And finally, we print or have a print statement that says print passed, and in this case, passed is not in quotation marks. That means we are printing the value inside of that variable called passed. Have a comma separator, then we have quotation marks, passed the exam. So let's say we went through the program and 39 persons passed. Then that print statement will now read print 39 passed the exam. And finally we have a stop. Quickly, let's look at what the flow chart would look like. So we have our start. Then we have our initialization. Go straight into the for loop, which of course goes into a diamond. Some people call it rhombus. Well, not rhombus, but diamond. And notice this is 1 to 40. And we're following a yes path now going down. So we're at the start of that for loop. You might be saying, then how is it that I is 0 and then now that it is 1? We're moving on. And in most programming languages, a for loop actually initializes the variable it is using. So I equal 1 is kind of an initialization. However, we should not substitute that for initialization itself. In the for loop, I becomes 1. But we want to give it an initial value before we make it become 1. Then we have print score in that yes path, a connector, A, that links it now to read score. Then we're going into the if statement that checks the score. And if of course we have nothing to do when the person has failed or gets something lower. So that path is empty to the left with the no. But moving to the right, we have yes and we increment or increase the value of past. That goes into another connector, and that other connector leads us back now to our loop. And as long as we are within the limits of 1 to 40, then we will always come back to our loop. And the connectors have been labeled B, etc., A, so that you can see what's going on. At the point at which I becomes 41, we have to exit the loop. And that is where I now have a connector that leads you straight to the end of your program. In this case, it's C. And we finally print past and print past exam, or whomever or how many has passed the exam. Same thing as in the pseudocode. All right? And then finally, we have the Pascal code. And this, of course, you can digest as you go